All right, let's get started. My name is Peter Anderson, and I'm an EMEA Development and Application Platform Technical Strategist, a very long title, but what it means basically is that I take care of CASP and CAP in EMEA on the strategic level. With me, my colleague Peter.
Yeah, my name is Peter Lundberg. I work as a pre-sale from Sweden. And I'm joining here today with Peter, helping out with demos.
So everyone in Sweden is named Peter, as you can guess. If you have any problems understanding my strange dialect or my Swedish, yeah, don't hesitate to shout out, because I'm Swedish and English is not my native language. All right, let's get started. So this is the agenda. Yeah, the introduction, we had that. I'm going to talk a little bit about the architecture I'm using for this demo-based introduction to CAP. And as it is a lot of demos in here, I'm scared, so I have a little ritual to the demo gods, so I'm going to sacrifice something. So make sure that they are happy and love me, and make sure that my demos goes well. And here are the demos I'm going to run. And the idea behind this presentation is that when I started to work with CAP, or try to figure out what the heck is CAP and Cloud Foundry, for me it was a big problem. Before I saw a couple of demos, I used it a little bit, then I understand, oh right, this is the idea behind it, this is why we should use it. So my hope is that I can bring that to you guys as well. So you will, after this presentation, understand, okay, what does CAP do, and Cloud Foundry, and when should I use it? So that's the idea. And as the other guy said, you have a survey afterwards. Please give me feedback if I managed to successfully give you this information or not. Yeah, next one. So this is the idea behind CAP or Cloud Foundry. It is very boring in the best way. You write your code, you push it, and you don't care where it runs, or how it runs, or why. Well, you care about why it's running, but of course, but you don't care anything about the infrastructure or anything. You just run it, and you use the famous command cf push to achieve this. Yeah, I think I missed that slide about the demo ritual, so I'm going to sacrifice a PCI controller, adaptive PCI controller to the demo gods. So it's a 2940 ultra-wide controller I found in my basement. So now I hope they are happy. So this is the architecture I'm using. I'm using Azure, and I'm using AKS. If you were here, the last presentation told you about CASP. So I do not have a CASP implementation here. I'm using the native Azure infrastructure from Microsoft Azure. So basically when I installed it, I used 3 virtual machines, and I have approximately 4 to 5 pods. So that's what that's what SUSE add to the environment, is that we can deploy the whole environment using standard Kubernetes commands and infrastructure around that, like Helm and others. So I installed first UAA, that's the user authorization authentication, which is one Helm chart, and then I installed CSF, which is the SUSE Cloud Foundry, and using another Helm chart, and so on. So, and this is me, I'm green and happy, so I will be the developer today, showing how to deploy software and use it. Next one. So actually, now I'm going to do the first demo. And if you can't see the screen, please let me know. So, just to make prove to you that I'm using Azure. Get pods. So now what I did run now is a command that shows all the pods. No, sorry. kubectl get nodes. So that's what I wanted to run. Yeah. So you can see the name of the screen is cutting a little bit. Let's see if I can.
So do you want to bring the top?
Sorry?
Do you want to bring the shell screen at the top? The command line? Yep, there you go. Thank you.
So, can you see everything? Yeah, it cuts it. So these are the nodes that runs my whole environment. Three of them. These are the pods I'm using, or that I have installed. Spaces. Ah. So this is good, yeah. So as you can see, there are a lot of pods running. So a kube system, that's part of Cube. Kubernetes metrics is something I installed. That's something that SUSE provides to the community. That is how you can measure and see what it contains. And it's using Stratus as its framework. And CSF, that's actually Cloud Foundry, which has a couple of pods in here, and the user authentication and authorization. So if we go back to my presentation. So basically, the path I'm using is this one. I'm using Microsoft AKS here, which has on a public cloud. Okay, makes sense? So now I'm going to do my first push, a demonstration showing what is really happening in here. So what I have is an application, very, very simple and stupid. So this is a Ruby script that does not do much, just say, hi, I'm your first CAP web app. So what I do is running CF push. So what is happening now is that the system takes care of a lot of things, and I'm going to show you what it actually happens in here. So when I do the CF push, it communicates with the UAA and makes sure that I'm allowed to push code to it, and I have logged in before. It compresses everything I have in the directory where I'm standing right now when I run the CF push, and create a zip file and send it up to Cloud Foundry, to something called blob store. And Cloud Foundry start the container and start analyzing what do I get, what type of code do I get, and depending on what type of code it was and how I defined what to run, it downloads Buildpacks. So the Buildpacks is actually taking care of the building of my application. If dependencies are needed for the Buildpack, it downloads that as well, and it creates something called a droplet. A droplet is a container in the Cloud Foundry world, and stores that in the DB and removes the staging environment, and then it starts the droplet. And it also creates routes to it. So in this case, I'm going to connect to my app that I created and store that in a database. So this stores the routing as well. So when I connect to my Cloud Foundry environment, it understands where I'm supposed to go, to which droplet I'm going to connect. So it does that. So this is what it looks like. It downloads a lot of stuff and creates the application called web app, and it got a route which is randomly in this environment. So what I will do now is use my web browser and go to that application. Hooray, it worked. So this is my first push and my first application. All right, so to prove that I'm not, yep, question?
So you're using a container offering of Cloud Foundry but executing in Azure, is that what's happening here?
Yeah, sort of, yeah. But I don't need to take care of that as a developer. I have my code and I just push it. I don't need to take care of or understand if it is Kubernetes or whatever it's under beneath, or how the network is working or anything. I just take my code and push it.
Well, I guess maybe I'll rephrase the question. So is Azure offering a containerized version of Cloud Foundry, the offering?
No, not really. So what? Yeah, it's and a product manager wanted to answer that a little bit better.
The SUSE Cloud Application Platform and the modifications we've made for Cloud Foundry allow it to run on any modern Kubernetes environment. So that's either SUSE CAS platform or EKS or AKS or GKE, etc.
Yeah, so when I look at his initial chart, he was almost implying he wasn't using CAP. That's what I'm
I'm not using CAS.
He's looking at it from the technical projects, so he's using all of the technical elements of CAP. That is UAA and Stratos and CF, but he's looking at more at the technical side.
Thanks. All right, to prove that I'm really pushed an application and used it, I'm going to modify it. So now I'm a developer and will do some code changes to it. So my super complex application here. So I created a new feature, the subject app. So if we run CF push again, so now everything that I described earlier is going to happen again. So it's compressed the file, everything in my home directory or the directory I'm standing it, push it up and start building it and start it. And everything like routing and creating storage and creating the droplet and everything is made automatically. And that is managed by Cloud Foundry. So it's worked, so it has the same routing. So if I do a reload of this page, you see, so it has added that thing I added as well. All right, makes sense? So, and the interesting thing, now I'm comparing to if you have a virtual environment and this is all the things a developer needs to take care of to make sure an application can run if you're doing it the traditional way. And if you're using containerized environment or Kubernetes and create your containers, manage the containers and everything, you need to do a lot of steps and take care of that as a developer. And make sure that you have a database, that you have storage, that you have the middleware, the operating system is updated in your container as well. But while using Cloud Foundry, you don't need to take care of that because that is taken care of by infrastructure. Just enter command CF push. That's the whole idea behind Cloud Foundry. Yeah. And if you look a little bit about what we at SUSE has done, is taking a lot of different parts of Cloud Foundry. All these pieces here are parts of Cloud Foundry which we have containerized. And the reason we're doing that is that to make it smaller, less footprint, and also run it in a modern environment like Kubernetes. So operators know how to handle it, how to scale it, how to log it and see what's happening and so on. But one of the main features is that it takes much less footprint. I run it in 3 servers, quite small servers in Azure, and if you want to deploy it the standard way or the old-fashioned way, you need like 4 to 5 virtual machines or something like that to be able to run it. And that's quite a big difference. Yes, question?
Sorry for the newbie question.
Yeah.
When you did that provisioning, it allocated memory and it allocated disk drives. How does that happen?
Run a couple of AKS commands.
So it's just a script that's in the background? So
we haven't documented this is how to do it. I have created a script that takes that documentation and just run it. Yeah.
Thank you.
Okay, perfect, thanks. And you saw this picture in the last presentation. This is actually what it's doing under the hood. And if you installed it, download the source code, and try to implement it yourself, you need to take care of all these connections, understand how they work and troubleshoot it. But that's what SUSE is doing for you, and creating more or less a couple of Helm charts that connects everything, and package it to pods. All right, now it's time for Peter number 2, Peter L, to take over.
Just to confuse you.
Take the microphone. Need a microphone.
I guess we got around. Okay, we're going to talk a little bit about logging and why is logging important. Well, if you want to do troubleshooting of your application, you need some kind of logging. And it's also part of something called 12-factor application. And what is that? Well, it describes principles how you should develop your code to make it portable and easy to change in the future, etc. So what I'm going to do now is to show you a quick demo on how to look at the logs. So I will get the logs and I will SSH into a running container. Let's see here. Which one is it? Yeah. So first I'm going to go into our application running. Maybe you should turn your off.
It's off.
Okay. So we have an application here. So first I'm going to push this. And then after this one is done, so now I'm pushing another application to Cloud Foundry. You can see it's doing a lot of stuff here. So first I'm going to have a look on the logs. So this is something I can do from my development laptop or whatever you're using. And as you can see here now, the application itself is just pushing out some text to standard output. And this is the thing when you're running an application in Cloud Foundry, a microservice or whatever, that you really just want to stream out the logs, look at the logs as a stream of events that you push out to standard output. Don't build any castle handling or logging inside your containers, just push it out and you can take care of it outside your containers. So if I would like to go even deeper and do some troubleshooting on the actual container application, I can do that also, because Cloud Foundry provides something called CFSSH. So what it's doing now is creating, you can think of it like a tunnel into your application or container. It's actually doing this via a proxy and standing up a copy of your application in the background. So it's a lot of stuff going on. But basically I have now a shell access to my container. Seems broken.
It's a small room to speak.
Yeah.
You're fine.
So if I then, yeah, have a look with you.
Oh, you guys.
Yeah. Seems okay as long as I have it like this. Maybe it's because of my pacemaker, no, I'm just kidding.
I'm on one foot, and
Yeah.
don't know both of them, but
Which
that
number
one
is it?
works.
2.
Turn one down a little bit as well.
Okay. Hello? Hello?
I'll start going as you talk, here, I'll start.
Yeah, it's on. Hello? 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 Good. So now I've just run the command here to check on the running services to simulate some troubleshooting. And as we can see here, we have a couple of services running. And one of them is the Ruby script we just saw that will sending out commands to standard output. And yeah, I mean, this is ordinary container, so I can do whatever I want here within the overlay file system. So basically, troubleshooting whatever you need to do here. And that's it about logging, so back to you, Peter.
All right, thank you.
Peter number 2.
Number one.
Number 1, sorry.
All right, so the next thing we're going to talk about is what I call scaling and auto-healing. So a very cool feature in Cloud Foundry, it makes sure that the application is running and continuously monitoring that. If something happens to the application, it restarts it if it's needed. And that's something you don't need to take care of or program or anything. If you do running it in Kubernetes, you have to put a couple of rules that does that for you. But in Cloud Foundry, that is automatically done. So I'm going to show a little bit of a demo about that. So I have an application which I'm going to push quite soon, and then I'm going to crash it and show to you how CAP take care of that and how to start it. So I have one application here, certify resilience, and it's called imperfect app, so we push that. So while that is happening, I can show also what we call, or something called Stratus, which is a add-on that SUSE is providing to the community around Cloud Foundry, which is giving the administrators a possibility to interact with the Cloud Foundry by using graphical tool. So these are the applications I have pushed so far. As you can see, it's time glass. Is that correct English word? Hourglass. All right. Sorry. And because it's pushing it right now, but I have a couple of others, as you can see. So if we go into one of them, like the web app, you can see the routes created, for example. So I click here, you can see some metrics and see how it's doing, and so on. And this is things that SUSE has added to Cloud Foundry. Right? So let's go back here and see. Okay, it has been up running, so we can go into it and see how it behaves, or use that. So we have one instance of it, and yeah, so I can reload it. But what I can do in SUSECAP, or sorry, in Stratus, is looking at how does my application, how is it doing. So you can see it here. So for example, one thing I can do is change in the number of instances. So quite easy, just push the +1 button, and I start a couple of other instances. So I want to show this, showing 2 screens at the same time. This is the idea. All right. So, but if I reload here, you can see that I get connected to different instances every time I do reload. And this application has a very nice feature. It can be crashed inside the application. So just push the button crash me, then that application will be crashed, or that instance will be crashed. So what I will do now is crash a couple of them. and see what happens. So what you can see is things starting to happen here, that it detects that it crashed and restarts it automatically, and that is taken care of by Cloud Foundry. And if I reload this page, you can see that I come to different instances, so now all of them are running. And I can crash them again, a couple of them, and see what's happening. So in some cases you can catch actually that it detects crashing here as a status. So, but it's restarted so fast we cannot see that. And you also notice how easy it was to scale up the application. Normally in Cloud Foundry world you don't need to do that scaling because that is taken care of also by Cloud Foundry. If it detects that this application is running out of resources, it automatically creates another one. But in some cases you want to do it manually. But in most cases it's taken care of by the platform as well. And that is also something you need to take care of if you're running Kubernetes, creating scripts and rules around that, but in Cloud Foundry you don't need to do that. So the next thing I'm going to show is a little bit something I call smooth deployment. And the idea is that we have one version of an application and you want to move to a newer version, but we don't want to do that in one big stage or one big jump or leap. So what I want to do is actually deploy one version of the application and make sure that that is running and working, and then as a developer I want to introduce a new version of the application, but just let a few persons or 20% of users use that first, and then smoothly, gradually move over so the new version is the only one that is used. Does that make sense? Everyone got that? Yeah? So how do I do that? With the help of Cloud Foundry. So if I go into my, so we have a super simple application here called Web App. And if you looked a little bit closer when I run some commands, we have a manifest that describes a little bit how it should be, what it should happen when I run CF push, some definitions. So if you look at the manifest, this one is the standard one, so it creates a random route and so on, and how much memory it's using. But what I have done is created a modified manifest, which I'm going to use, where I force the route to it. And how many instances of it. So what I do is now we modify my application to make sure that it's right. Oh, shit, I did it wrong. So what I do now is creating the first version of this one, CF. Let's see if I have correct model. Yeah, I did. So what I do now is CF push -F to tell that it's going to use my modified manifest. And as I told it to have a new name, it's going to be created as a new instance. Cloud Foundry don't know that I already pushed the same application more or less. So it detects it as, or treats it as a new application. So if we go to applications here in Stratus, you can see that it's working, or should be working at least. Yeah, so this is the one that I pushed right now. So let's wait for it to be ready and started. So the demo god hit me maybe. Yeah, let's try it again. It looked good. But some rumors says the network is a little bit shaky, so hopefully it gets through this time. because what is happening is that the CF push command, what is happening is it communicates back and forth with Cloud Foundry. So if the network gets some hiccups, yeah, the push fails. So you get the feedback from Cloud Foundry what is actually happening, and that is a communication that is encrypted with HTTPS, and make sure that that's working. No. Ah. Yeah. So what I can do is try to kill some applications, CF apps. So what I can see, run in command line to see what I have. So maybe I'm running out of resource or something. I've never seen this before, but I can CF delete. Use the cable. Is that any ideas from engineering? What is happening?
Talk to IT.
It's not connecting to something, I don't know what happened.
Pardon?
That's good.
So what I will do is go in here and see if I can delete some applications from here instead. Delete. It looks like it has deployed, so let's see if it is working. Yeah, looks like it. So yeah, got some.
It's working, it's just having that communication.
Yeah, something with communication, but the app itself is working, and that's yeah, that's good. So so what I want to do now is show you that what happens is that I can push out or start a couple of more instances of the same application. This is version 1. So every time I reload the page, I get a new instance. I don't care which one, but that is what's happening. So as a developer, I have developed version 2. So that's what I'm going to do right now. Just change it to version 2, and also modify the manifest. Manifest. So rename it to something else. But notice that I'm using the same route. So 2 different applications does have the same route, and this is one cool feature with Cloud Foundry, that it handles it for me. So I don't need to call the networking guys and make sure that they connect everything, and make sure that the load balancers and the other stuff are handling this for me.
Can you make the V2, because it's starting to cut off the first 2 characters. No, in the config.rs.
Okay, sorry.
Just because
Yeah, got it.
the projector's getting it off.
So if I do it like this,
Or, yeah, you can't see the V2 in the window.
ah, all right, now I got
Say
it.
V2,
Now I got it.
V2.
All right, or move it to Windows. So, all right. So, sorry about that. So now I created a new version of this application, and what I do now is run a CF push again, and using my modified manifest. So notice that it creates a new application here because I modified the manifest and told it this is a new application, but it's using the same route to it. And the idea is that as I have 4 instances of this one and 1 of the new version, so every 5th time I connect using that route, I will connect it to the new version, and 4 out of 5 times I will be using the old one. Does that make sense? Everyone? Yeah? So now I'm the user using this. So every time I push a reload, I can show with big how I do that. So every time it's using the old version, but soon every 5 times it will be using the new version. Just need to wait it to be pushed correctly. Are we time-wise? Quite good?
Yeah.
I need some help later on. All right, that's all right. So now it's been pushed. So what? Now I've pushed reload once. So it's using what? Twice, 3 times, 4 times. Yeah, there it is. So now it and 1, 2, 3, 4, 5. It gets to the new version. No, I missed it. There it is. So now you can see that most of the time I reload it, it goes to the old version, but every 5th time it goes to the new version. And as the users give me good feedback, they like the new features, we are smoothly deploying away from the old version, the version 1. So that's super easy to do by using Stratus. So what we can do now is killing some instances here. Just push the minus button, so we have only 1 instance of this instance. So, sorry, if I do the load again, now every 2nd time it should be there. Yeah, and yeah, everyone is happy. So then we kill the old version, just pushing -1 here or minus button. And as Stratus is rather smart, it tells me, are you really sure you want to kill the last instance of an application? That does not make sense to me, but that's out of Stratus' perspective, but I confirm that that's exactly what I'm going to do. So now everyone is killed. So every time I do reload, I will get to the version 2 every time. Alright? So this is how simple it is to do smooth deployment by using functionality in Stratus. Or, sorry, in Cloud Foundry. Alright, the last demo I'm going to show is the most tricky one. So I really hope the demo gods are with me. So what I'm going to do now is show something we call a stateful app. If you're following the 12 application development, how to develop using cloud native applications, you should not have stateful apps and store the states somewhere else. And the reason is that you should be able to move them around, kill them, and start up many of them. And the application itself should not contain a state. It should be somewhere else. For example, in a database. So I'm going to show you how to do this. So I'm going to connect one of my applications to a Redis database in the backend and show that it is using that. And also how easy it is done by using Cloud Foundry. And yeah, let's show it. So this is the work, the workflow. I create a Redis service. I push my app, and then I connect the Redis app together with my app, and then I start the application. And then it's using Redis as the backend for stateful storage. All right, let's do that. So I have one app here called shared states. Stateful app. So what I will do now is just CF push that one, and I will tell the system to do not start it, just push it. So it will be shipped up, the droplet will be built, but it will not be started. And the reason is that it needs some storage in the backend, so I need to connect it before it starts. So, and the system tells me also now you don't have an app in running instance of it. So how do I do this? So we have something called Marketplace, CF Marketplace. And one thing I really like with Cloud Foundry is also the commands are quite easy to understand. So here you can see that I have a couple of services installed in my environment: MariaDB, MongoDB, Postgres, and Redis, and different plans. So in in many environments, these services cost money, and you can have different plans that gives you different performance. If you're using SSD storage or spinning disks or whatever, you can use different plans, and someone takes money for it. So you choose which plan you want to use. In this case, they are named very stupidly: 4011, 4010, and so on. So what I'm going to use is this one, 4011. So I run the command cf create service, and I'm going to use the service redis, and then I tell which plan I'm going to use. It's 4-010, and connect and tells the name of it. Stateful app redis. So now I create a service instance, and which is the Redis database in the backend. Give me OK, and then we can look at it. So if you run cf services, you can see what type of services I have running in my environment right now. So I have two of them. I have another demo application which I'm not going to show today, but this is the one that I created right now. And as you can see, it has not any bound applications to it. So the other one is bound to one application. But what I'm going to do now is bound it to an application. So I run command cf bind services. Bind service, and which app I want to bound to it. Stateful app, that's the name of the app, and to what service? Stateful app redis. So this is the service name, and this is the app. So now I bind them together, and then I can start my application. So cf start stateful app. Yeah, waiting for computers is always fun, isn't it? Alright, so now it's up and running. Now I can show what it looks like. So I connect to it. So this is my stateful app. So every time I reload it, you can see that it counts up how many times I connected to it. And if we scale it out, it should be here. There it is. Instances. So if I create a new instance of it, and reconnect to it, every second time I get to instance 1 and 0. And as you can see, this one detects also differently depending on which instance I'm connecting to. And how is this done in the backend? It's quite simple. It's just environment variables that is shared between these two, the service and the application itself. So if you run cf stateful app, you can see that it has a couple of environment variables and tells how to connect to the Redis database. So this is shared between it and set up when I run the cf commands. So that's also a very cool feature that you not need to share passwords and have functionality for that, because that is taken care of by Cloud Foundry. Alright, so I'm just going to show you what happens if we scale it up a little bit more. So let's see. Start instances. So now I can see it connects to different instances and keep track of them. And I can also scale down as well, and it keeps this stateful thing in the backend. All right. Any questions, comments? Does it make sense? Yeah. Cool. So this is what I hopefully showed to you today. That Cloud Foundry is actually working this way. Here's my source code. I push it. I don't know, and it starts, and I don't care how. All right. I'm done. Thank you.